Hello people. If you want to solve the problem, because I did not explain how to use a fermat point. If you want to solve the problem, use a fermat point and pause the video here. I didn't explain it because this video is more for me than for you. And actually, I don't think anybody will be watching this, so it's fine. Anyways, bye. Okay, so let's take a look at what we have here. We have a rectangle. We have a rectangle that has a width of 4 and a length of 6. Okay, and we also see some lines in the triangle. They connect at point P, right? And I forgot to do something, but basically we want to find the shortest possible distance of AP plus DP plus PE. So we need the shortest distance of these three lines. So now I'll go back, and what we want to do, let's take this triangle and let's rotate it 60 degrees. Okay? So we are going to rotate ADP, this triangle. We are going, okay, well, I don't have the triangle, but let's pretend this is ADP rotated 60 degrees. And let me try to make it line up. Ugh. Okay, pretty much it lines up. Okay, great. So basically it lines up now, and let's put a little equilateral triangle to show that it has been indeed rotated 60 degrees. And now this is actually Fermat's point, and basically you want the points E to this, like it lines up so that there's the shortest amount of distance. Now let's take in this one, D1, right, because this is just point D rotated 60 degrees, and then we have frick, okay, P1 rotated 60 degrees, and P1 would just be over here, right? So we have the equilateral triangle to show that it rotated 60 degrees, AP1P, and then we have the APD rotated 60 degrees, which is AD1P1. So let's look at how we can find the distance of AP, DP, and PE, okay? So first we know A to D1 is 6 because AD, this is 6, right? It's just this part rotated, and AD is 6 because that's the length of the rectangle. Oh my god. Yeah, I need a better app than Google Slideshow, but here it is. Okay. And now, let me put a line over this because, line. Yeah. Okay. And, for this one, we need to figure out, okay, so let me put an additional point here. We'll call this point O, alright? So this is where, right, it's not a very straight line, but it's supposed to be AD. It's where P1 to E meets A to D, right? And that would be point O. And because they're perpendicular, because we know that it has to be a straight line in order to have the shortest amount of distance, because Fermat says so or whatever, right? We know that this is 90 degrees. So this one is also 90 degrees. Boop. 90 degrees. Whatever. Frick this. Let's just write 90. You guys know, right? You'll know. Okay, so P1 to O to A, that's 90 degrees, right? You can see that the equilateral triangle, right? We have this line which divides it into two, which means that the top half of this triangle, this is 30. Then the bottom part, OAP, that's also 30. Then D1A to P1, that's also 30. So we know D1 to A to O, that's 60, okay? And so I was actually following a Chinese video about this, and I got confused on this part. But basically, if you have a 90, 60, 30 triangle, that means the base will be half of the hypotenuse. And I'm not sure why. I asked my friend, and that's what she said. She said it's just a rule in math that you should know, I guess. So, okay, well, it's 3 now, right? Now, since we have this, now that we have the 3, 6, we have the hypotenuse and the base, we can calculate what D1 to O is, right? I'll just paste that in. Basically, 6 squared, which is a hypotenuse, equals 3 squared plus D1O squared. This is a Pythagorean theorem. Right, so 36 equals 9 plus D1O squared. 27 equals D1O squared. So the square root of 27 27 equals d1o. And then 3 square root 3, which is just the simplified version of the square root of 27, is the length from d1 to o. So just like get that in. Yeah, I had another one, but it wasn't like very clean, so I'm trying to do it again. But here it is. So d1 to o is 3 square root 3. Okay, now we know that OE is 4 just because, you know, it's the same as the width. Oh, I think my parents are talking about this problem, but yeah. So this one is just 4, okay? And now you're like, oh, we did all these calculations, but how does that help us, okay? Well, for one, we know that AP is the same length as AP1 and P1P. Wow, why is this useful? This is an equilateral triangle, so all the sides are the same length. But we can see that this part, P1 to P, is the same as AP. So then we actually have AP figured out. We have this part, right? Then D1 to P1, that's just DP, right? And then PE is just the remaining. So we've actually figured out the lengths of this line. So although we don't really know what P1 to P is, or what D1 to P1 is, or P to E, we have their combined length, which is 3 square root 3. 3 square root 3. Ooh! Plus 4. Right? So AP, it matches up with this part, P1 to P. D to P matches up with D1 to P1. And then EP is just EP, right? So we found the combined sum of the two parts, but that actually gives us the 3 parts of the line. So, alright, the minimum distance for AP plus PD plus DE equals 3 square root 3 plus 4.